So today we're going to look at day 2. It's over many pages more than normal, just because it takes a lot of steps, not tons of steps, but it's sort of leave lots of room for you to work, right? And so today's lesson on day 2 focuses on this part of our original diagram. Right? How do you go from some data and create the equation? Last time we had the equation, we made it our table, then we graphed it. But now we're going to have some data. We're going to look at how do you create the equation. And remember, all of our equations that we had for our line last day sort of look like this, right? We had a number in front of the x plus another number, or maybe minus another number. So we have these two numbers in the equation we need to figure out. What is this coefficient? Remember, a number from the x is called a coefficient. And what is this number? A number all by itself is called what? Starts with the C as well. Do you guys remember that? Going back to our polynomials unit? Constant, yeah. So to figure out equations, it's going to look like that. So I'm going to go to our day 2, right? We have an equation like this. We need to figure out two numbers. We have a number that goes in front of the x, which is our coefficient. And we have a number that's all by itself that we're adding or subtracting, which is our constant, right? All right, so those are the two numbers we need to figure out for our equation. Because the rest of it is going to be like y equals and the x part in there. All right. Okay, so now, instead of just giving you a table, sometimes you're often asked to count things and make your own table, right? And this is where students go wrong so many times, not because they can't count, they don't fully read the questions. So be very careful when you give it a question and you count the thing they're asking you to count. Sometimes they ask you to count sides, sometimes they ask you to count shapes, sometimes they ask you to count outside sides. So you have to read the little sentence very carefully and make sure you're counting the thing that they're asking you to count. So here, they're asking us to count the perimeter. How many sides are in the perimeter? Remember, perimeter is the distance around the outside. So we have our first diagram right here. So diagram 1. How many sides are in the perimeter there? 6, right? 1, 2, 3, 4, 5, 6. Then we have our second diagram here. How many sides are in this diagram?
Do we count where they're connected?
It says perimeter. So if you use the word perimeter, does this spot in the middle count?
No.
No, because we're looking for outside sides, right? So yeah, you got 10? Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? Now, what's happening here? Let's not draw all these, but let's just draw the third one. What's happening with each time? Each time, what's changing between diagram 1 and diagram 2? You get a new hexagon. The 6-sided thing is called a hexagon. You're going to learn that about chemistry. That's a benzene, sort of looks like a benzene ring. So if we draw the original one like this, and so we start off with figure 2. It's going to look something like this, right? Then we add on another hexagon. We can add it onto the top or we can add it onto the bottom here. It doesn't really matter, but we'll add one on. I'll go like this. 1, 2, 3, 4, 5. Okay. So figure 3 should sort of look like that, right? What is your perimeter for figure 3? How many sides are there? How many do you have? On the out. 14. You got it right. There's 14 of them. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So figure 3 has 14. And this is not a very fun diagram to redraw. And if you wanted to draw figure 4, we're not going to draw figure 4. If we drew figure 4, how many sides would there be on the outside?
18.
18 says Reese. How do you know it's 18, Reese?
I don't.
It goes up by 4.
All right. It goes up by 4 each time. So Jacob noticed that, hey, it went up by 4 each time. And he's right. And noticing this pattern in the table gives you the first number in your equation. So this pattern that you see, how much it goes up by, or maybe sometimes it goes down by, that is your coefficient. Okay? So now, we're going to start creating our equation. It takes a couple of steps. Right? Set up your table, figure out your coefficient. So we have an equation that's going to look like this. Y is equal to 4x. So that 4, the pattern, is how much is going up and down. That's your coefficient. Now, we just need to figure out the second part of this. What number do we add or subtract to make this equation work? Okay? That's the constant. To do that, all we do is we test out how well our equation is working so far. So we go like this. This is our so far made up equation, right? We have 4x, right? So we go, remember where we see an x, we put our little bracket signs in like this, right? And let's see how well it works. We stick in our x value, right? We go stick in the number 1. 4 times 1 is 4, but our answer should have been 6. Right? So what number do we need to add or subtract to make this equation work?
Plus 2.
Plus 2. We need a plus 2 here to make it work. So our equation should be not y is equal to 4x, but y is equal to 4x plus the extra 2 to make it all work. Right? So now, often we can make little mistakes in our head trying to figure out what the number is we add or subtract to make it work. What we do is we do an extra little check. There you go. Okay, let's just pick another spot on the table here, and let's just check if the equation we made is right. So we pick any spot you want. Let's go like this. Let's go, I don't know, I'll pick somebody here. Leland, what spot do you want to check? 2, 3, or 4? 4. We'll check right here. All right? So our equation is 4x plus 2. So 4 brackets plus 2, like this. We stick in the number 4. Hopefully we get the answer 18 out. 4 times 4 is 16. 16 plus 2 equals 18. And it works. All right? You can check with any other spots. It will always work. So you come up with the number that you add or subtract, and you just double check you to see if it works. So now, before we continue on, right? This is how equations of lines look like. Y is equal to 4x plus 2. Y and x's are generic letters. We want to use more meaningful letters. So when we go to use this equation, it makes more sense. Here, our x column is figure number, and our y column is sides, x and y. So use letters to represent that. So how about we use sides instead of y, or s? I'm going to write down the word sides because sometimes s's look like 5s. Right? So instead of y equals, let's say sides equals. A little bit more meaningful. Instead of x, let's use figure number. Use the letter n for x. So there's a little bit more meaningful, right, in our context. So this is like a much, much nicer equation to work with. Right? So that's the hard part. Right? So now we have an equation, and this equation represents the pattern that we see happening here. And we can use this equation to figure out future values. So the next question goes, hey, we have a diagram 13 somewhere down in the future. How many sides will it have? We could do option 1 is go 5, 6, 7, and just keep on adding 4, adding 4, adding 4 a whole bunch of times, get our answer. If you get stuck, that is completely valid. Or we use our equation. Sides equals 4n plus 2 is our relationship. We want to put figure number 13 into our equation. So there's 2 spots where we can put numbers in. Either we put in numbers for sides or numbers where the n is. Where do you think you put this number in?
The N.
N stands for figure number, right? So we take out the N, we put brackets there, and we stick in the number 13, right? And we do that calculation, right? And we just figure further down. So you go 4 times 13, which is, you can use a calculator, 52. 52 plus 2 is 54. That's it, right? The 13th figure will have 54 sides. Okay, that's it. Right? So let's do one more of these. Right? The next one goes somewhere in the future. There is a diagram that has 82 sides. Where is it? Which figure number is it? And Reese says 20. How did you figure out, Reese?
Use the calculator.
And what did you do with your calculator?
I just literally counted up.
You just literally counted up?
I counted.
You can do that. That's completely valid. You can keep on adding and counting, but I can easily change this number from 82 sides to something like 1,000 or something. In that calculator method, then even though you can still do it, it becomes much more painful.
I just
So,
4 times 11 all the way up.
right, so we want to use this equation. This is the equation for our pattern. We have the number 82 here. What does 82 replace? Does it replace the sides or does it replace n? Sides. This is 82 sides. So you stick in 82 in for sides. Oops, let's stick the number 82 in green. Here, 82 equals 4n plus 2. All right? So now we need to figure out what n is. So this becomes a question from last chapter. Right? We need to solve for n. We split at the equal sign. And we cover up the side that doesn't have the letter. Would you get rid of the 4 or the 2 first? 2. We will add, subtract, multiply, or divide. Subtract. Subtract. The 2's go away. You have a 4n. You have an 80 on this side. You want to get rid of the 4 now. How do you get rid of the 4? Divide. Opposite calculations. We divide by 4. We divide by 4. The 4's go away. 80 divided by 4? 20. So you do have to solve some equations in this chapter, but that is as difficult as it gets. Nothing as crazy as what we did in Unit 5. So this was like a day 2 question, right? And this is something at grade 8 level. That's what, right? You're going to add or subtract first, then you're going to divide second. Right? That's as hard as it can get for this chapter. So we can say the 20th figure has 82 sides. That's it. Okay. Now, right, so far, 3 questions I can ask you. Come up with the equation for this pattern. Then the other 2 questions are using it. You're finding either an x value or y value. Find out the figure number or figure out how many sides. Those are the 3 main questions. One that sometimes throws students off is this question here. It says, can you describe the pattern? And that's where you just look at the pattern. You say, hey, each time the sides grows by 4, right? And then you just put that in your words. All right? The number of sides increases by 4 in each figure. And that's it. Right? So I'll do one more question like this with you, then we'll call it a day, I think. All right? Okay. So let's go to the next page. All right. So here we have this diagram going on. We're comparing figure numbers to this diagram. That's what the triangle is growing. So what are we counting? Are we counting triangles? Are we counting lines, inside lines, outside lines, all lines? What is it asking us to count?
Triangles.
Just how many triangles are in each diagram. So we have our first diagram right here, right? That's easy. There's only one triangle here, right? Then we have our second diagram right here. So you'll figure number 2. How many triangles are in that one?
3.
1, 2, 3, like so. Then we have our third diagram. Third diagram here. And that one has 5. 1, 2, 3, 4, 5. Okay, so now we need to draw the fourth one. We won't draw the fifth one. This is a very common pattern, right, that shows up in your following years. And sometimes students struggle to draw it. I tell students, hey, notice the triangles in the bottom. That increases by 1. We have 1 triangle here, 2 here, 3 here. So when you get to the fourth one, just draw like 4 mountaintops. So draw a line here. Draw 4 mountaintops. 1, 2, 3, 4. Then just connect the peaks. And you have your next diagram. So this is a very common one. Sometimes students often struggle with it. That's a quick way to draw it out. So draw 4 mountaintops and just connect the peaks, and you have your fourth diagram. All right. All right. So the fourth diagram, which we drew. How many triangles are there? 7, thank you. Then the fifth diagram, which we are not going to draw. But you look at the pattern, you go, oh, it's going up by 2. Thank you, Channeline. So there is 9. Right? So noticing that it goes up by 2 each time, that's your coefficient in front of the x. Right? So you've got half the marks right for your equation right there. You know it's y is equal to 2x. Right? So we just need to figure out what number do we need to add or subtract to make this equation work. So we go back here. We go 2. We put our brackets in. We stick in our x value. We get the answer. 2 times 1 is 2. What number do we need to add or subtract to make this equation work?
Subtract 1.
Subtract 1. So you go minus 1. So y is equal to 2x minus 1 is hopefully our equation. So we just find another spot on the table to double check to see if we did it right. So pick any spot, it doesn't matter. All right? All right, so which one do you guys want to try this time around? Doesn't matter? Let's try the fifth one again. And on the bottom, just gives us more space. Let's try that one. So we have 2 brackets minus 1. All right? We stick in the 5. And if we did the answer completely equation right, the answer should be 9. So 2 times 5 is 10. 10 minus 1 is 9. And it works. Okay? That's it. Now, let's use more meaningful letters because they'll come in handy for here. So instead of y, we're counting triangles. So let's put down a T for triangles. That's a little bit easier to understand. Instead of x, let's use n for figure number again. Or maybe the letter F for figure number. Doesn't really matter. There we go. All right. So we created our equation. You've done the hard part. The next 2 questions are just using the equation. Right? So the next goes, hey, we have figure 71. How many triangles are there? And you can do like what Reese did. Just make the table longer and keep on adding or adding 2 each time. But that would take a very, very long time. But then we just go, okay, let's use the equation. T equals 2n minus 1. Where do we put the 71? N for the T or N for the N? What is figure? Is figure T or is figure N? Which one is it? Somebody. Anybody? N, thank you. I just want to make sure you're understanding it. So 71, oops, let's do it in green. goes here in brackets instead of n. Everything else stays the same. Right? 2 times 71, so double 71, that'd be 142. Minus 1, so we go 141. So we can say a little sentence. The 71st diagram will have 141 triangles. All right? All right. Let's do the next one again. This time, it's saying we have 63 triangles. Which figure is it? So we start off with the equation t is equal to 2n minus 1. Where do we put the 63? Where the t is. So you go 63 here equals 2n minus 1. We split at the equal sign. We cover up the side that doesn't have the letter. What's our first move? Move the 2 or move the 1? Yeah. So it's minus 1, add 1, add 1. The 1's go away. 64 equals 2n. All right? Get rid of the 2 by dividing it. All right? Divide 2. Divide 2. N equals half of 64, which is 32. So we can say the 32nd diagram will have 63 triangles. And that's it. So next day, we'll do some warm-up. So if you look at the third page here, it's tables. I'm not asking you to count anything. I've already given you things to count, or already pre-counted, and we're just going to figure out the equations. All right, that's it.